Okay, this video goes over homework 10 solution, which is on hypothesis testing for one population. We're testing a mean against a known value. The first question is, why would we use a z-test versus a t-test? And the biggest reason is that if you don't know what this population standard deviation is, then you should use a t-test. And I would argue that's almost always the case. The other idea is that if you have small sample sizes, the t-distribution is preferred if you don't know what the underlying distribution is. And if you have large data sizes, the t-distribution mimics the normal distribution, so it's okay to use the t-distribution even if the z would be appropriate. So I would argue you could always use a t-test. The rest of these problems are solving using the 6 steps of hypothesis testing. The first one is that we've got this bad debt ratios, and they want you to determine if the bad debt ratio average is greater than 3.5%. So we assume that it's not, that it's equal to 3.5. We try to prove otherwise. We set alpha. We calculate a t-stat based on our sample data. We have a sample average, a sample standard deviation, and the count. 0.035 is what we have over to the right of the mean, so that's what we're assuming is true, 0.035 or 3.5%. We can calculate the p-value. Since we're looking at a one-tail greater than, then the p-value, you calculate 1 minus t-dist. You put in your t-stat, your degrees of freedom, which is the sample size minus 1, and the last argument is always 1. This number is smaller than this, so you reject the null hypothesis, which means this is not true, which means this is true, which means the bad debt ratio is greater than 3.5%. Problem 29 is almost identical. We just have more data. We're looking at satisfaction ratings, the sample average, the sample standard deviation, and the sample size. The null hypothesis is that we're assuming it's 42 and trying to prove that it's greater than 42. Well, it is. It's 43. The question is it statistically greater than 42? Or is that just because of error, randomness? So we set an alpha. We calculate a t-stat. The t-stat is the sample average minus 42 all over the standard deviation divided by the square root of the sample size. We get a t of this. The p-value is 1 minus t-dist of 2.91. Degrees of freedom is 64. Last argument's 1. That number is the p-value, which is the probability that this is true. It's very small because it's smaller than alpha, so reject it. Reject this, which means that we do have evidence that satisfaction is greater than 42. Problem 30 is we're looking, instead of looking at satisfaction, we're looking at wait time, and we're trying to test if we have statistical evidence that it's less than 6. We calculate a sample average and a sample standard deviation based on a sample of 100. The sample average is 5.5. The question is that statistically different than 6? We set an alpha and we calculate a t-stat. In this case, the t-stat's negative, but that's okay. That doesn't impact us one way or the other. A t can be positive or negative. It's 5.5 minus the 6 all over 2.5 divided by the square root of 100. And then the p-value, since we're doing a less than, we don't do 1 minus, we just put t.dist. Then we compare this to this. This number is smaller, which means we can reject the null hypothesis, which the waiting time is greater than or less than 6 minutes. We have evidence that that's true. The last problem, a small data set. The null hypothesis is that we're assuming it's 750 pounds per hour, and we're trying to prove that it's different. So we're trying to prove that it's either bigger or greater than 750. We set an alpha. We calculate the t-stat. The t-stat is based on the sample average minus 750 all over the standard deviation divided by the square root of the sample size. It's a very large t. It's positive. So how we calculate the p-value is, since this is positive, we calculate the p-value by taking 2 times 1 minus t-dist of the t-stat, degrees of freedom, and the last argument is always 1. If that would have been negative, we wouldn't have done 1 minus, would have just done 2 times t-dist. We calculate a p-value, it's smaller than that, we can reject the null hypothesis. So yes, we have evidence that the yield, if I spelled it correctly, is greater than 750. Now, we were trying to prove that it's different. It is different. We have evidence that it is. And since this number is positive, then we have evidence that it's different, but it's different because it's bigger. So we can not just say it's different, we can say it's greater than. All of the problems that we did, we rejected the null hypothesis. I'll argue in the real life, it doesn't happen that often. Most of the time, you fail to reject the null hypothesis. Most of the time, you don't have data to say something is different. But in this case, we do. Okay, that's the homework. Thanks.